Okay, guys, we have another chemical equation. This one's going to be more on the difficult side because you might have noticed, and I'm going to highlight it in red, we have an oxygen with each compound in this chemical equation. Okay, you see that? So this is going to be a little tricky, but we'll work through it. So I'm going to do, how I'm going to start is how I've been starting with these videos is I'm going to divide our reactants from our products just to make it, just to simplify it, nice organization. So again, we're going to start by identifying each element. So we have a potassium, we have an oxygen, we have a hydrogen, and we have a carbon, right? So I'm just going to do the same in the same order on this product side. So we have a potassium, an oxygen, a hydrogen, and a carbon. Okay? So now that we have them labeled, let's just count them. So we have one carbon, we have one oxygen here, and then we have two oxygens here. So for our total count, we're going to add them. So one oxygen plus two oxygens is going to give us three oxygens on this particular side. We have one hydrogen, so we're going to put a 1 here. And we have one carbon, so we're going to put a 1 here. Now, on our reactant side, on our product side, we have two potassiums. So I'm going to put a 2 here. We have one carbon, so I'm going to put a 1 here with the carbon. And for our oxygens, we have 3 oxygens, and then we have 1 oxygen. So 1 oxygen plus 3 oxygen is going to give us 4 oxygen. So I'm going to write that there. And then we have 2 hydrogens. Okay? And make that 2 stronger. Okay. There we go with the hydrogen. Okay. So as you already noticed in going through this chemical equation is not balanced. We have 1 potassium over here. We have 2 over here. 3 oxygens on this side. We have 4 over here. 1 hydrogen on this side. 2 over here. The only thing that's balanced in this equation for the moment is our carbons. That's it. Now, I will say that the first thing that we want to do is find the simplest element to balance. And at the moment, being that oxygen is affiliated with each compound in this, that's not going to be our best choice because it will confuse us. The thing that's really leaping out at me in the moment is our potassiums. Seems to be kind of like our loner. So we have 2 here. Let's just see what'll happen if we go ahead and balance our potassium on this side to get 2 over here. We have a coefficient of 1 here as it's understood. So let's go ahead and multiply this potassium hydroxide compound by 2, which will give us a check and balance for our potassium. And let's see what happens. So in doing that, we get 2 oxygens here instead of the 1. And then we get 2 hydrogens instead of the 1. So let's go ahead and change that. But here, so if we change that, being that now we have 2 oxygens, we still have to account for the oxygen, the 2 oxygens that are over here. So now that we have this coefficient of 2, so we have 2 oxygens here plus the 2 oxygens over here, that gives us 4 oxygens. Okay? And now let's see. Let's do our checks and balances now. Let's see if this is enough. So if we look over here on our reactant side, we have 2 potassiums. We have 2 potassiums on our product side. We have 4 oxygens on our product side. And now we have 4 oxygens on our product side. On our reactant side, we have 2 hydrogens. Look at that. We have 2 hydrogens on our reactant side. That's all it needed.